Hello, this is a lab report on oscillation. The purpose of the lab is to examine the change in energy in an oscillating system. I use two models for this lab. One where I analyze the video of a mass vertically and horizontally oscillating, and a computer model where I coded the same mass oscillating and compared that data to the data of the video. The physical principle I used was Newton's second law, and in this lab I discovered that the change in total energy remained constant during oscillation. For the physical principle I use, which is Newton's second law, it essentially states that net force is the derivative of momentum, which can be interpreted as either net force equaling mass times acceleration, or net force being the sum of all forces acting on an object. I use this in the lab to help calculate the acceleration of the mass. In the video, a mass is hanging vertically by a spring behind a wall in a room. A man releases the mass at an angle such that it oscillates in both the y and x plane. The system in this video is the spring, the mass, the person, and the earth. The surroundings would be the airflow. Then I used a video analysis app to track the motion of the mass and create two position versus time graphs for both the x position and the y position, where I found the initial condition being positioned where it is 0.107 and 0.629 meters, and the initial velocity, which is just 0. For the computer model, I divided it into 4 different sections. The first one being visualization and graph initialization, where it sets up the visual representation of the simulation. It initializes the blue sphere as the computer mass, red sphere as the video mass, blue curve as the computer's trail, cyan helix as the spring, and yellow sphere as the spring's origin. Then it creates graphs for the x and y position and the change in energy over time. Then it uses G-curves to plot the data from both the video and the code. Then there is the system properties, initial conditions, and data section, where it defines the following properties and conditions: the mass of the object, the initial position and velocity, which are the same as the video, and the time steps. It also imports position data from the video. Next, there is interaction constant, spring, and energy section, where it defines the following constants: the gravity constant, the spring constant, and the relief length of the spring. It also calculates the following properties, such as the current length of the spring, the change in length of the spring, the kinetic energy, the gravitational potential energy, the spring potential energy, and the total energy. For the calculation loop section, it runs until time reaches about 9 seconds, and in that loop, it initializes the initial energies for both kinetic, potential, and total to their corresponding current value in the previous section. Then it calculates the force of gravity, the force of spring, and the net force by adding the two together. Then it updates velocity by using Newton's second law, where it is updated by net force divided by mass times timestamp, and then it updates position by velocity times timestamp. It also updates the current length and change in length by the same equation used in the previous section, and the same thing is said about each energy. Then it calculates the change in each energy, including total. Then it updates the simulation and graph with the current data in the loop, and then time is incremented by the timestamp. In this lab, while the change in total energy remains constant, the change in gravitational and potential energy oscillate inversely with each other, while the change in kinetic energy changes in its own rate. The error in this lab is that the math in the video did not have the same frequency as the computer model. This could be because there was error resistance in the video that was not taken into account in the coding. For the modeling system, the energy principle is satisfied because the change in total energy remains 0, as there were not any external forces acting on the mass in the model. Using the data I obtained, I have found that the period of oscillation from the y position and the x position are slightly different mostly because of air resistance. This is the end of my lab report.